Decades after World War II ended, most of the world believed the Nazi regime had vanished, its scientists dispersed, its secrets lost or destroyed. Yet hidden in the shadows of Europe, a small faction of engineers and physicists quietly worked on a project that would have pushed humanity to the moon decades before NASA existed. This was Project Silbermond, the so-called Silver Moon Initiative, a lunar-based concept that never saw the light of day, but left traces in classified archives and declassified intelligence reports. The origins of Silbermann trace back to the final years of the Third Reich. As Allied forces closed in, German scientists accelerated research into advanced rocketry, nuclear propulsion, and long-range space travel. While Hitler and his generals focused on weapons that could win the war, a handful of visionaries imagined a far greater prize: humanity's first steps on the moon. They were inspired not only by military necessity, but by ideology, a desire to create a permanent outpost that could project power beyond Earth, a monument to German technological supremacy. Central to the project were engineers who had worked on the V-2 rocket, the first long-range ballistic missile. These men, including some of the brightest minds from Peenemünde, envisioned rockets capable of reaching lunar orbit. Unlike the V-2, designed for destruction, these new prototypes were intended to deliver cargo, equipment, and even personnel to the moon. The plans were ambitious: modular lunar habitats, pressurized cabins, and even rudimentary life support systems, all powered by liquid fuel engines far more advanced than anything seen in the late 1940s. Archival photographs, mostly black and white and grainy, reveal test facilities buried deep underground. Engineers are seen inspecting rocket engines, poring over blueprints, and calibrating instruments. Many of these images were confiscated by Allied forces during Operation Paperclip, but some remained hidden in Soviet archives for decades, only resurfacing in the 1970s. They show experimental launch pads in remote forests, tunnels reinforced with concrete, and vehicles that resemble lunar landers on a scale smaller than the final envisioned designs. Project Silbermann was divided into three phases. Phase 1 focused on building rockets capable of leaving Earth orbit, essentially a test bed for propulsion and navigation systems. Phase 2 aimed to design a semi-permanent lunar base, a series of interconnected modules that could sustain a small crew for months. Phase 3, the most audacious, imagined a fully operational lunar colony that could expand as technology advanced, serving as a springboard for further exploration of the solar system. None of these phases were completed. The first challenge was propulsion. The V-2's design, while revolutionary, was insufficient for a lunar mission. Engineers experimented with multi-stage rockets, combining multiple V-2-derived engines to achieve greater velocity. Some tests were successful, achieving suborbital flight with heavier payloads than any previous design. Secret documents show calculations for fuel mixtures intended to optimize thrust while minimizing weight, a delicate balance that could mean the difference between reaching orbit or crashing into the Atlantic. Simultaneously, life support became a critical concern. The concept of pressurized cabins was still in its infancy, and oxygen recycling systems were rudimentary. Engineers sketched modular living quarters, including sleeping areas, workstations, and observation windows. Water and air recycling mechanisms were theorized but never fully prototyped. Despite these limitations, the designs were remarkably advanced for their time, anticipating many solutions later implemented in the Apollo program. The lunar base itself was envisioned as a series of silver-colored domes connected by tunnels, positioned in regions of the moon that would allow year-round sunlight for energy. Concept sketches reveal radiators, solar panels, and storage compartments for scientific instruments. Some modules were designed to be prefabricated on Earth, then assembled by astronauts upon arrival. Others were intended to be built using lunar regolith, a concept decades ahead of its time, showing the engineer's awareness of resource constraints beyond Earth. Yet for all its brilliance, Silbermann was doomed by circumstance. The fall of Nazi Germany in 1945 abruptly ended funding, displaced the team, and scattered the archives. Many scientists were absorbed into Allied programs, particularly in the United States and the Soviet Union, where their knowledge fueled early rocket and space efforts. Some were quietly absorbed into Soviet lunar projects, their contributions unacknowledged and classified. Others were recruited by the Americans under Operation Paperclip, contributing to Redstone and Saturn rocket development. In this sense, Silbermann may have indirectly shaped the space race, even though the original lunar base was never built. Despite its failure, Project Silbermann left a trail of artifacts. Blueprints, photographs, and experimental engines were seized, archived, or hidden. Occasionally, these items surface in obscure declassified files, hinting at the scale of the project. One particularly revealing document, stamped Top Secret, describes a multi-stage rocket capable of reaching 40,000 kilometers per hour, with payload capacity sufficient to transport small modules to lunar orbit. Another sketch shows a circular lunar habitat, roughly 10 meters in diameter, with provisions for airlocks, storage, and a central command station. The secrecy surrounding Silbermann was meticulous. Internal memos instructed scientists to destroy sensitive materials if discovery was imminent. Test sites were hidden in forests or mountain tunnels, shielded from aerial reconnaissance. Reports even indicate the use of decoy rockets and false telemetry to confuse Allied intelligence. For decades, historians dismissed these references as exaggeration or myth. Only after declassified documents emerged from both American and Soviet archives did the outlines of Silbermann begin to take shape. The human cost of the project is largely unknown. Many engineers continued their work in secrecy, enduring harsh conditions in underground labs. Some documents hint at experimental tests on human subjects, though evidence is limited and often speculative. The secrecy, combined with the chaos of post-war Europe, ensured that personal accounts were rare and most stories were lost or suppressed. What remains are the blueprints, photographs, and calculations, fragments of a vision that could have rewritten space history. Interestingly, Silbermann illustrates a paradox of technological progress. While conceived as an instrument of ideological dominance, its designs anticipated solutions adopted by both the American and Soviet space programs decades later. Multi-stage rockets, modular habitats, oxygen recycling, and lunar construction from local materials, all these concepts were explored in some form during Silbermann's brief existence. Though the project never launched, it foreshadowed humanity's eventual reach into space, a hidden chapter that history almost erased entirely. Modern analysis of Silbermann's feasibility suggests it was technically possible, but extraordinarily risky. Calculations indicate that with the materials and fuel available in the 1940s, the rockets could have reached lunar orbit, but a manned landing would have faced near-certain failure. Structural integrity, life support reliability, and navigational precision were all untested at this scale. In short, the lunar base may have existed on paper, but the human cost of attempting it could have been catastrophic. Some historians argue that Silbermann's influence is evident in post-war space programs. Wernher von Braun, who had worked on these designs, applied similar engineering principles to Redstone and Saturn rockets. The Soviets, too, benefited from former German expertise, accelerating their lunar ambitions. In this sense, Silbermann never truly died. It became part of the DNA of the space race, a ghostly blueprint for humanity's first ventures beyond Earth. Rare photographs add depth to this story. Images of engineers measuring rocket components, testing fuel mixtures, and annotating blueprints show a meticulous attention to detail. One photograph shows a partially assembled lunar module prototype, its metallic surface catching light through a narrow tunnel window. Another depicts a team huddled around schematics in a dimly lit lab, smoke curling from a small stove used for heating chemical samples. These images, faded and scratched, are more than historical artifacts. They are glimpses into the ambitions of a team that dared to imagine the moon decades too early. Silbermann's legacy also raises questions about ethics and secrecy in science. The project combined brilliance with ideology, ambition with danger. Its suppression, intentional or incidental, may have saved countless lives while denying humanity an early path to the moon. Yet the knowledge generated in those tunnels and labs did not vanish entirely. It was absorbed, adapted, and ultimately became part of the collective human endeavor to explore space. By the late 1950s, the original documents and hardware had either been destroyed, relocated, or hidden in government archives. Project Silbermond faded from public consciousness, surviving only in the memories of those involved and in classified intelligence reports. Today, historians and space enthusiasts can piece together fragments of the project, but the full picture remains tantalizingly incomplete. The moon base that could have been remains a phantom, a testament to human ambition, ingenuity, and the shadows of war.